Hello everyone, I am Siddharthan. The topic we have for today is machine learning model deployment, and in this video we will be discussing how we can deploy a trained machine learning model using Streamlit library in Python. So we will be taking the diabetes prediction project which we have already worked on in our channel, and we will be creating a web page where the user can give in some values and this trained machine learning model can predict whether a person has diabetes or not. So this is the web app that we are going to create in this particular video. So let's get started. So first of all, I'll go to my diabetes prediction code in my Google Collaboratory. So as you might know, I have already made this video, and if you haven't seen that particular video, if you don't know how this thing works, I'll give the link for the diabetes prediction project in this video description. You can check that video out, and after watching this video, you can continue with this one. Okay, so these are all the basic data processing and all those things. So I have already uploaded my dataset file, which is this diabetes.csv, and we have did this, importing the libraries and all other things. So the complete code is here. So what I'm going to do now is, so I'm going to my runtime and I'm running all the cells. Okay, so this will run the entire cells. So in this, the model we are using is a, now you can see here it is a support vector machine classifier. So we'll be saving this trained model and we will be using it to deploy in our web app. So once we have completed all the things, so once we have trained our model, once we have evaluated our model, so finally we have this predictive system where we can give some values in this particular list, and it will tell you whether that person is diabetic or not. So this is what we have done in that particular diabetes prediction project. Now we can see how we can save this model, how we can save this trained support vector machine model, and how we can use that in our Streamlit code. Okay, so I'll just make a text here as saving the trained model. So saving the trained model. So for this we need a library called as pickle. So I'll write here as import pickle. So this is one of the libraries that you need for this particular project. So I'll run this. So this will import the pickle library, and this pickle library has the functions that we need in order to save this model. So I'll create a variable here as file name. So in this variable, I'm going to give the name of the file that I'm going to create. So I'll name this as trained model, trained underscore model dot sav. Okay, so it is basically a saved file, and I'm going to use the function pickle dot dump. So pickle dot dump, and within this I need to give the model. I need to mention the model that I want to save. So here we have named the model as classifier, right? So I'll copy this classifier term, so you can paste it here. So pickle dot dump classifier, and we need to mention open and file name WB. So let's try to understand what we are doing here. So these are some file operations that we are doing here. So I'm naming this particular file as trained model.sav. So this is the name of my file that I'm saving, and I'm storing this in a variable called as file name. So in this file, I wanted to save this particular model. So I'm using this pickle.dump, and I want to save this model, and this model is loaded in this variable called as classifier. So I'm basically opening a file, and the name of this file is trained model.sav. So I'm mentioning the file name here, comma WB. So W means write, B means binary. So we are writing a file in the binary format, and what we are writing is nothing but the classifier, the model which we have trained using the diabetes dataset. So in this we have used a PIMA diabetes dataset. So you can see all the details here. So it is basically helps you to predict whether a woman has diabetes or not. So the input features we have are the number of pregnancy a particular woman had, what is their blood glucose level, blood pressure, and so on. So this is one of the standard data sets that we have in machine learning. And finally we have the outcome, one being the person is diabetic, and zero being a person is non-diabetic. Okay, so this is the data set that we have, and this model is trained with this data set, and it is this classifier term. And now we are storing this model to this file. So it basically contains all the parameter values, so weights, bias, and other parameters of this particular model. So when I run this will create a file called as trained model.sav. So I'll run this. Okay, so this will create a file. So you can see the file here. So trained model.sav. So this file gets created. Now let's see how we can load this model and how we can use it. So this part is about loading the saved model. So this is also very important for you to learn. So let's see. So we have now saved our model. Now let's load this. So I'll create a variable here as loaded model. So in this term loaded model, I'm going to load my model. So is equal to, again I'm going to use pickle function called pickle.load. So this dump function is used to save your trained model, and this load function is used in order to load the saved model that we have saved. Okay, so here also you should mention open, and within that mention the name of the file. Okay, so the name of the file is nothing but trained model.sav, right? So I'll copy this and paste it here. So it is nothing but this particular file. You can also go to this option and copy the path and paste it here. So I'll just paste the name here, and here we should mention RB. So RB means reading the binary formatted file. So first we have written the file here. So hence we have used this attribute WB, and now we want to read this file and load it to this loaded model variable. So we have to mention this RB, which is the parameter here. So this pickle.load will load the saved model that we have. So let's run this. So now this loaded model will contain the model which is actually trained with the diabetes dataset that we have, and this particular model has an accuracy of around 77%. Okay, so the only difference in the code which I have shown here from the diabetes prediction project which I have worked on is that in that particular video I have used the standard scalar function, but in this case we won't be using the standard scalar. The reason is that the accuracy doesn't change, so it is almost the same when you standardize and don't standardize the data in this particular project. So the reason I didn't include that is, in case you are using the standardization function, you need to save the standardized that standardization function as well to your pickle. So that's why I didn't mention it, because it might be too much to handle right now. So first of all, let's try to understand how we can save the model, and we can work on that. So afterwards, let's see how we can save that standardization function and all that. So I didn't include the standardization part in this particular code, so that part will be missing when you compare it to the diabetes project which we have worked on already. Okay, so that is one difference. So we have successfully loaded our model. So now what I'm going to do is I'm going to copy this entire thing. So I'll paste it here. So here we have used this classifier, the classifier which we have trained using the data set. Now I'm instead of this classifier, and I'm going to use this loaded model, which it's basically the same model loaded from the pickle. So I'll paste it here. So this will also give you the same value. So one, which basically means the person is diabetic, and the new data is this. So now what we are going to do is use the saved model. Okay, so this loaded model in order to predict whether a person is diabetic or not. But the only difference is that we will be creating a web page where there will be a user interface where the user can give in these details, what is the number of pregnancies, and what is their BMI, what is the blood sugar level, and so on. And our web app will predict whether that person is diabetic or not. So this is the goal that we are interested in. So now I'm going to save this model. So trained model.sav. So you can go to this option and download the file here. Okay, so it is actually a very small file. Okay, so now I'll minimize this and I'll go to my spider. Okay, so the spider is the IDE which we will be working on in order to build this user interface using the Streamlit library. And in my previous video I have explained you what is or how to install the Anaconda, and how to install Spider, how to install Streamlit library, and so on. I'll give the link for that video as well in this particular video description. You should watch those videos before watching this one. Okay, so now what we are going to do is, so I'll just import the basic libraries that we need. First is NumPy library. Import NumPy as np, and then I'll import pickle. So we need this pickle library because we are going to load the data, load the model, right? So for that also we need pickle, and you should also install this pickle library. And if you are in Python 3.8 version, so if you install the Anaconda, so the default Python version in the Anaconda is 3.8, and for that you need to install the pickle library. So for that purpose you need to run pip install pickle mixin. So in my previous video I have shown you how you can do this pip installation. And so what you basically have to do is you need to go to your Anaconda, and you can go to this environment, and you can go to this play symbol. There you will see an option called as open terminal. So there you can paste this command called as pip install pickle hyphen mixin. So this is the version of pickle which is suitable for Python 3.8. so install that library, and there are also other libraries like NumPy, matplotlib, and other things. So install all the basic libraries that we need. So I'll close this. Now what we are going to do is we are going to do the same thing that we have did here. So we will be loading the pickle model and we will try to predict this particular data. So I'll copy this, loading the saved model. Okay, so I'll go to my spider. So I'll paste it here. Now we should mention the location of this trained model.sav. So where that particular file is saved. So I'll go to my downloads and I'll copy my trained SAV. Okay, so this is the model that we have downloaded, the trained model that we have downloaded. So just create a separate folder and work on this particular folder. Okay, so I'll paste this here. So I'll just change this numbering. Okay, so the name of the file is trained model.sav. So now in this, I need to mention the path of the file. So I'll go to my directory and I'll copy the path where this trained model is saved and I'll paste it here. Okay, so trained model.sav, and you need to mention the slash. Okay, so now the important thing is that whenever you are working in Python, so it should be a forward slash should be used for this directory location. So I'll change all the backward slash into forward slash. So model, train model, and yeah, so now the code knows where this particular train model.sav file is, so it will load this model to this variable and we can use this loaded model in order to make new predictions. So I'll go to the next part, and now we are going to copy this code. Let's paste this in spider. Okay, so now we can run this and see whether this is working in spider or not. So this is the same thing that we have worked on Google Colab. So now we are going to do the same in Python, in this spider IDE. So once you have pasted this code, you can go to this run option. So this will run this file. Okay, so the label we got here is 1, and 1 is basically means that person is diabetic, right? So we get this particular statement as this person is diabetic. So we are going to do this same thing now. The only difference is that we need to showcase this everything in the form of a web page. So what we will be doing is we will be creating a function and we will be including all these things in the form of a function. So this is the next part. So before that, we need to save this file. I'll go to this and save my file as, so I think it is stored in a different directory. So file, save as, I'll go to the folder in which I'm working on. So I'll name this as predictive system. Okay, predictive system. So it is a Python file. So the extension is .py. Okay, now let's go and let's create a new file, and this is where we will be using our Streamlit library in order to create our web app. So this part of the code will begin with importing the basic libraries. So the libraries that we need are NumPy, just a second, NumPy, Pickle, and Streamlit. So I'll give import NumPy as np, and I'll import Pickle, and the last library we need is Streamlit. Okay, so Streamlit is used for deployment, Pickle is used for loading the saved model, and NumPy is used for working with those NumPy arrays. So we just need to copy and paste all these codes. The only difference is that we need to put this in the form of a function. So I'll copy this part of the code. Okay, so let's start with saving this file. So I'll save this as in the same folder, and I'll name this as diabetes prediction web app. Diabetes prediction web app.py. So let's save this. Now let's create a function. So I'll put a comment here as creating a function for prediction. So in my previous video, I have explained you what all these things mean. So why we are converting it to a NumPy array, why we are reshaping it, and what all these things means. Okay, so you can refer that video if you're not sure. So we are going to create a function now. So for that, we need to use the keyword def, which basically means define, and I'll name this function as diabetes prediction. And within the parenthesis, let's mention this as input data. Okay, so input data is nothing but the data that the user has to give. So you can see the data here. So all this details the user has to give. So whenever we are calling this diabetes prediction, so we need an input, and that input is nothing but your input data, which tells you, those things, the number of pregnancies, BMI value, and other, basic things. So now let's complete this code. So it's basically the same thing, the predictive system that we have built. I'll copy this and let's paste it here. So make sure the indentation is same. So the indentation line should be the same in this case. And we just need to, just make one thing, one change. So instead of this print, I'm going to write it as return. Okay, so return, and let's remove this parenthesis. And the same thing here, return the person is diabetic. So what we are basically doing here is, so first we need to get the input data from the user. Okay, so we don't need this, so we don't need this particular line because the data is pre-made here. So I'll just remove this. Okay, so what we are doing here is, so whenever we call this diabetes prediction function, so the user will give in the input, and once it is done, so we are basically converting that input data in the form of a numpy array. Okay, so that's this second line of code. So we are creating a numpy array using this input data, and after that we are reshaping it in order to make prediction. Prediction is nothing but this model will predict whether the value is either 1 or 0, where if it is 1, we need to tell that that person is diabetic. If the label value is 0, then we should say that that person is not diabetic. So once we convert it to a numpy array, we are reshaping it. After that, we are using this predict function. So this predict function is in the SPM library. Okay, so the library, the classifier which we have trained. Okay, so we are using the loaded model. So the model which we have loaded using the pickle function. So once we load the model, and we are using this predict function, and this prediction will be stored in this variable called as prediction. So label, in the sense, the value that you get from here will be either 1 or 0, and we are storing that in this term called as prediction. So it will be in the form of a list. So this is the term prediction. Okay, so this is nothing but the term we have mentioned here, prediction. So it is basically a list which contains only one value. So the value which is present in this list is 1. So if the value is 0, then we should return the statement as that person is not diabetic. Sorry, if the value is 0, okay, so we should mention not diabetic. If the else condition, so the other condition is the label will be 1, and if the label is 1, we should mention that that person is diabetic. Okay, so this is the code that we have worked on. Now we can move on to the Streamlit part, where we will be building some user interface. So now let's come out of this function, and this part is using the Streamlit library. So for this, I'm going to create a main function. So there is a reason why we are naming this as main. So I'll explain you at the end of this code. So for now, just remember that we are creating a function named as main. Okay, so main function. So the first step is giving a title for our user interface, a title for our web page. So I'll make a comment here as giving a title. So for this, we should use the function from Streamlit. So, and the other thing is we can import this Streamlit as st in a short form. Okay, so we are importing Streamlit as st. Okay, so giving a title, so st.title. So this title is the function within the Streamlit library, and within the parentheses give any name, so the any name you want. So in this, I'm going to name this as diabetes prediction web app. So this is the name of my page, and now we should create some data fields, some input data fields, where the user can give in some values. So all these values, so if you come to this data set, so the data that you need should be the same as the data that you have here. So if your data contains pregnancies, glucose, blood pressure, and so on, so the user also should give the same values. So same, I didn't mean that it should be the same values that is present in this data set. So what I mean is, so you should give the pregnancy values, glucose value, blood pressure value, and so on. Okay, so now we are going to create this input data fields. So that is the next step. So we need to see what are all the different fields that we have. So totally we have about 1 2 3 4 5 6 7 8 9. So totally there are 9 columns, and out of this 9 columns, the last column is the outcome column. So this is the target column, which says whether a person is diabetic or not. So we shouldn't mention this. So apart from this outcome column, because the model predicts this particular outcome column. So apart from this, we should mention all these 8 columns from pregnancies to age. Let's see how we can create those input data fields. So this part is about getting the input data from the user. Okay, so let's create all the variables that we need. So I'll go to my data set. So I'll open, so I have my this dataset file in my desktop. I'll also give the link for this dataset file in the video description. You can download the dataset from there, and I'll open this in my notepad file. So we have all these things: pregnancies, glucose, blood pressure, skin thickness, and so on. So I'll just copy all these things except outcome. So we are going to create 8 variables. So this is just for reference purpose. Okay, so first we should mention this pregnancies. Okay, so pregnancies is equal to, so once we are done with this code, I will delete this particular line. Okay, so pregnancies is equal to st dot text input. So this text input will get the data from the user in our user interface. So st dot text input. So we have this text input function from Streamlit library, and you can mention some name for it. So number of pregnancies. And the second variable that we are going to create is this glucose, right? So I'll just copy this and paste it here, and we can change this to glucose. So we should do the same thing for all the 8 terms. cst.text, this will give us the glucose level. Okay, so blood glucose level, and the third thing is blood pressure. Okay, so I'll copy this blood pressure, and now we need the blood pressure value, which is basically the BP value. Okay, so blood pressure level or blood pressure value. So what this particular term in quotes represent is, so there will be a data field where the user can give in the values, and above that data field, so this particular statement will be seen. So above that particular data field, there will be the statement called as blood pressure value. So the user can see that and enter appropriate value. So that is the reason for doing this. So these are all just variable names for those values. So only this thing will be appearing on our web page. And the third thing that we need is skin thickness, right? So or else I'll do one thing, I'll just paste this 8 times. So we have 4 and we need 4 others. Okay, so I'll see whether there are 8. 1 2 3 4 5 6 7 8. Okay, so we have 3 terms here: pregnancies, glucose, blood pressure, and the fourth term we need is the skin thickness value. So I'll just paste this here, and then insulin level, and BMI, diabetes pedigree function, and finally the age value. Okay, so now I can remove this. So okay, so now we can change the text that we want to see above the data field. So this is skin thickness, right? So let's write here as skin thickness value. So our model will predict whether the person has diabetes or not based on these values. So here let's write as insulin level, and the next is BMI value, which is basically the body mass index value. So BMI value, and diabetes pedigree function. So once we complete this, you can see how this user interface looks like. So diabetes pedigree function value, and finally what is their age of the person. So let's name this as age of the person. Okay, so these are all the 8 terms that we need. So pregnancies, glucose, blood pressure, skin thickness, and insulin, BMI, diabetes pedigree function, and ages. Okay, so now we can move on to the prediction part, where we will be calling this diabetes prediction function. So it will predict whether the value is 1 or 0 from the model which we have loaded using pickle. Okay, and then we can say whether that person is diabetic or not based on the labels that we are going to get. So now what I'm going to do is, so this particular part is the code for prediction, and all these things should be enclosed in this main function. Okay, so you can see the indentation here. So code for prediction. And in this I'll create a variable as diagnosis. So diagnosis is equal to, so I'm mentioning quotes. So two single quotes, one opening single quotes and closing single quotes. So you can also double quotes, it doesn't matter. So only is that you should have opening quotes and double quotes. So this is basically a null string, so a string that contain no values. So the reason is that, so we will give all these values to this particular function, so this input data, and this particular function will do all the processing and will try to predict the label which will be stored here, and we will try to check whether the label is 1 or 0, and the final output that we get from this diabetes prediction function is this, either this line or the second line, whether it tells that person is diabetic or not. So this string will be later stored in this variable called as diagnosis. So that's why we are creating an empty string here. So that's the reason for this. Now we can create a button. Okay, so what happens is the user can give all these values and can click a button called as predict. So when they click that particular button, they will get this particular diagnosis. Okay, so that's the idea. So this part is about creating a button for prediction. Okay, so for this I'm going to create a if condition. So if st dot button, so st being streamlit, st dot button, and we can name this button as diabetes test result. So you can give any names. So I name this as diabetes test result. Okay, and let's work on this if condition. So if this button is clicked, so we should predict the output based on the input that we have. So diagnosis, so we should store the final output. So final output is nothing but these two lines, either this line or this line. Okay, so diagnosis is equal to diabetes prediction, and within that we should mention all the 6 things here. So this diabetes prediction is nothing but the function that we have created, and within this list we should mention all the 6 things: pregnancies, glucose, and all the other values. So I'll just copy and paste all the things here. So first is pregnancies and glucose level, and the second one is blood pressure value, skin thickness, insulin level, BMI, so it should be in the same order that we have worked on. Okay, so that is very important. Diabetes pedigree function, and finally the age. Okay, so these are all the 8 terms that we need. So what we are doing here is, so we are, first of all, we are getting the input from the user. So that is done by this particular part of the code. So once we do that, there will be a button called as diabetes test result. So when the user press that particular button, so all these things, all the data that we got from the user, so the input data will go to this function which is diabetes prediction. So you can see here, so this diabetes prediction will take all these values through that input data, and all the processing will be done, and the model will try to predict the label whether it is either 1 or 0, and if the label is 0, it will tell that that person is not diabetic, and if the label is 1, it will tell that person is diabetic. So this is the test result that we are interested in. Okay, so that's it for this, and now we can finally say that if this is success, so you should come out of this if condition indentation, and here you should mention st dot success. So this is another function, and this will give you the final output, which is our diagnosis, right? Okay, so diagnosis. So we have created a null string, right? So we have created a null string, and we have stored the output of this diabetes prediction function into this variable called as diagnosis, and we should finally print this. And the last thing we should mention is if name. So you should mention 2 underscore and mention name again. 2 underscore is equal to, so this thing should be exact. Okay, so you can mention quotes here, and again 2_main, and finally you should mention main. Okay, so I'll try to explain what we are doing, trying to do here. So this particular file, this diabetes prediction web app, won't work if you just run this particular cell. So this code should be run from the Anaconda command prompt. Okay, so we have our Anaconda navigator, right? So we will open our command prompt and we will try to run this particular file from there. Okay, so when we run a file from the command prompt, so this file will, this particular code will take the name as main, and when that happens, only this main function will run. Okay, so this main function is nothing but the function that we have created for our web page. Okay, so the reason we are doing here is sometimes this file can be run on a different file. So just like we have imported the numpy and pickle and so on. Okay, so we can import this particular Python file through another Python file. So in that cases, this function should not run. So that is the reason. So this define function or define main function should run only when we open this from a command prompt, and that's why we are running using this particular line of code. So it will take this value as main only when it is running as a standalone file. So when it is running from a command prompt, or this file is running directly. Okay, so that is the reason we are doing this, and this is the general thing that we do in any Python code. So when we are trying to run this in a command file, or something like that. Okay, so this is the thing that you should do as such. So what we are trying to do here is, so first we are trying to import the basic libraries numpy, pickle, and streamlit that we need. So pickle is used for loading the saved model, and streamlit is used for creating the web page. And we are loading the model which we have saved from our Google Colab work that we have done using the pickle.load, and in that we should mention the directory of the file. So here the backslashes should be replaced by the forward slashes. So sometimes it may not work properly, so that's the reason. And we are reading the saved file as a binary format, so that is mentioned by this RB. So W means writing a file in the binary format, RB means reading a file in the binary format. And then we are creating this diabetes prediction function where it will take the input, and this input is nothing but our input data which will be given by the user, and it will try to make that prediction, where if the final prediction is 0, it tells the person is not diabetic. In other case, the person will be told they are diabetic. And then we are creating this main function where we can give the title from the Streamlit library, and the title here is diabetes prediction web app. And the important function that we are using as this st.text input. So this will get the input from the user. So after that, we are creating a null string, and within this null string called as diagnosis, all the the result, the final result will be stored. And if this button, so again we are creating a button now, and you can just give any name, and here I've given the name of this particular button as diabetes test result. And when this button is clicked, it will try to call this diabetes prediction function, and all the input data given by the user will go to that function, and we will get the final diagnosis. And when all this is a success, so all this has executed correctly, we want to print the diagnosis. So that's the idea of this particular file. So I'll go ahead and save this particular file, and I know what is the path of this file, right? So I have the path of the file here. Okay, so now let's run this from our Anaconda command prompt. So I'll open my Anaconda navigator, and I'm working on this machine learning environment. So I have a base root environment, and I have created another machine learning environment here. So I have mentioned this in my previous video on how to do that. So here I can open my terminal. Okay, so make sure to open your spider from the environment that you are working on. Okay, so that is very important. So all the libraries should be installed in this another environment that you're working on. So go to this machine learning, you can see this play button, and open the terminal from there. And here we can run our code. So there is a different way to run this. So what you should do is mention streamlit dot run. So this is very important. Okay, so this command, so streamlit space run, and you should create two double quotes, one opening double quotes and closing double quotes, and within this we should mention the path of the file. So I'll go ahead and copy the path of this particular file. I'll copy this, and I'll paste it here. So here it can be the normal backslash, the default file location that we have here. So you don't need to convert that to a forward slash. And we should also mention the name of the file. Okay, so the name of the file here is diabetes prediction web app.py, right? So I'll choose this, and I'll copy the entire file name along with the extension, which is .py. So here you should paste this. So include a backslash and paste the name of the file. Okay, so what we have done is we have mentioned this streamlit space run space. You should mention the path of the file that you want to run. Okay, so if you press the center, a web page will be opened. Okay, so it will take few seconds to get opened. So let's wait for it. So your default browser will get open now. So let's see. Okay, so this is a simple user interface where the user can give in the values and they can get the result as whether the person is diabetic or not. So these are the input data fields. So I'll open my dataset file. Let's try to use some values and try to predict whether the label is either 1 or 0. So I'll have those things side by side. Okay, so let's choose some value. Okay, so I'll choose this particular one. So this is the value I'm going to choose. So the label here is 1. So 1 basically means that person is diabetic, right? So we should paste all these things. So the first value we have is the number of pregnancies, right? So 2 is nothing but that person has 2 pregnancies. So we should put in that particular value here, 2, press enter. And the second value is 197, which is the blood glucose level, 197. And again press enter. So press enter once you fill in this particular data field. And the third value is blood pressure, and the blood pressure value is 70. And fourth one is skin thickness value, which is 45. And then we have 543 as our insulin level. Yeah, 543. And BMI value will be 30.5. Okay, and the pedigree function value is 0.158. 0.158. And the age is 53. Okay, age is 53. So I have given all the input data, and when I run this, you can see the button here. So there's diabetes test result button here. So if I click this, it will tell me whether that person is diabetic or not. And I should mention here that you won't get the accurate prediction for all the cases. So we know that the accuracy score of this particular model is around 77 percentage. So yeah, so we have the test data accuracy here. So 77 basically means out of 100 values we will get the correct predictions for 77 values. So that's the idea of it. So let's see whether we are getting correct prediction or not. Okay, so I'll go to my Streamlit, and now I can press this diabetes test result, and now it tells us that that person is diabetic. So we can check that out here. So the final label is nothing but 1. So we know that 1 means that person is diabetic. So this is how you can create a simple user interface where the user can give in all the values and they can see whether a particular person is diabetic or not. So let's try to do the same for a non-diabetic person. So we should get the label as 0. So it should tell that that person is not diabetic. So I'll try to reload this. I'll choose this value. So you can see this here. The label for this value is 0, which means that person is not diabetic. So let's try to put all these values here. So the number of pregnancy is 1, and the glucose level is 103, and blood pressure value is 30, skin thickness value 38, insulin level 83, BMI value is 43.3, diabetes pedigree function value is 0.183, and finally the age of the person is 33. Okay, so the label here is 0, right? So it should tell that that particular person is not diabetic. Okay, so let's get the diabetes test result, and it tells that that person is not diabetic. Okay, so you can see the label here which says 0. So this is how you can use this in order to predict what is the label and what is the corresponding statement, whether that person is diabetic or not. So you can get this diagnosis, and we should fill in all the input data fields here. So that's what we have built now. So you can see this title here, right? So diabetes prediction web app. So that's what we have given in this st.title line, and then we have created this 6 functions, right? So that's what is shown in this particular case. So you can see all the 6 data fields here, and you can see this names, right? So number of pregnancies, glucose level, and all those things. So those are nothing but what you have mentioned in this codes. And finally we have this button called as diabetes test result. So you can see that particular button here. So diabetes test result. So when you press that, you will get the diagnosis which tells us whether that person is diabetic or not based on the label we have predicted from our saved trained model. Okay, so this is how you can simply deploy a machine learning model using Streamlit in a web page. Okay, so I hope everyone is clear up to this particular point. So this is actually a very basic one. So there are a lot of things you can do. So you can have multiple tabs, like say for example, we have worked on multiple projects like Parkinson's detection and breast cancer detection and all that. So you can have different tabs here. So let's say that we have one tab for diabetes prediction, one tab for Parkinson's prediction, and so on. So when user clicks that, the corresponding data fields will appear, and the corresponding test result will be shown. So there are a lot of things you can do here. So you can add some images and all those things. So it's up to you. You can change the backgrounds and all that, so you can make this look good and all those things. So this is a simple way of deploying a model that you have. Okay, so I hope everyone understood up to this particular point. And in the future, let's try to work more on this Streamlit, and let's try to explore different things that are present in this particular library, and what are all the different things that we can do with our saved model. Okay, so that's it from my side, and I'll see you in the next upload. Thanks for watching.